So today we'll start up a new topic with the application of geoinformatics in various disciplines. So taking various themes, we'll be taking various applications, we'll be stating various departments how they are using it. So the prima focus themes that are the prime concern for investigation using remote sensing and GIS technologies, land, ocean, atmosphere, planetary. So, whatever comes to your mind, whether it is related to agriculture and crops, environment and forest, water resources, snow, glaciers, glaciology, mineralogy, rural, urban, regional planning, then marine, coastal, ocean, fisheries application, disaster management, global change modeling, atmospheric meteorological studies, planetary studies. So, using GIS and remote sensing techniques known as geoinformatics, we can use the entire subject and the satellite images for preparation of various kinds of atlases like four line changes atlases are being prepared using remote sensing and satellite images, then alpine terrain atlases, coral atlases, Wasteland Atlas of India, Desertification Atlas of India, Wetland Atlas of India. So you can see that all the atlases which are of prime concern to any of the departments is being prepared using geoinformatics. Now we'll be doing and seeing the various satellites how they are used for Earth observation satellites. So for the land and water observation, we are using resource set 2 launched in 2011. That is ReSat 1 in 2012. Then we have got high resolution satellite CatoSat 2, 2A, 2B in 2007, 2008, 2010. CatoSat 1 in 2005, ReSat 2 in 2012. For ocean studies, Oceansat 2 launched in 2009, Survey in 2013, SCASAT 1 in 2016. For weather and climate, INSAT 3 in 2003, Kalpana in 2002, Megatrophies in 2011, INSAT at 2013. So you can see that we have got a variety of data sets pertaining to the application. Whether you want to go for land and water study, whether you want to go for high resolution mapping, whether you want for ocean studies, whether you want to go for weather and climate studies. So for each and every study, we have got a different kind of data sets, satellite imageries that will be interpreting and will be seeing how these satellite images are used for various applications. So you can see these are the various satellite images representing the various Earth features. So, what are the departments that the remote sensing and GIS is used for geostationary as well as polar sun synchronous? We are going for fisheries studies. We are going for dairies. We are going for pest and disease infection. We are going for irrigation, health management advisories, water stress, plantation, crops, agroforestry, soil, horticulture, field crops, crop forecasting, planning policies. So, Earth observation mission can be classified into two categories, or we have got generally two types of satellites available with us, that is polar orbiting satellites and geostationary satellites. So geostationary satellites are commonly based as weather forecasting satellites, and polar orbiting are generally used for natural resource management. So, as per the policy, as per the objective, the different policymakers, planners, managers, industry, researchers, business intermediaries, NGO, farming continuity, each and every person is directly or indirectly connected with GIS, remote sensing, geoinformatics. We are using this technology in our day to day life, but we are ignorant that this is what GIS is, or this is what geoinformatics is. So we have to see that how this subject is changing our lifestyle, how it is making ease, how it's making the data more interpretable, visualizable, and more result oriented. So, what are the requirements? There are some of the requirements like you will be recording some secondary data, you will be recording country, district, block boundaries, optical data, microwave data, thermal data. It depends on whether you want to go for daily analysis, weekly, monthly, seasonal, annual, decadal. So all such kind of analysis, the GIS, geoinformatics, remote sensing has the capability of providing solution to each and every question that comes to your mind related to natural resources. So as we have already done, we have seen how the different satellites work in different electromagnetic spectrum, how the data are being recorded, how the sensors record the data in the form of digital numbers, and all the resolutions we have already studied. We have studied about the various reflectance of the earth objects in various spectral channels. So the we have already discussed, so I'll be not going into much detail about the various spectral responses, whether uh, there are different kinds of rocks or whether you talk about various kinds of soil. You can see that how the spectral profile varies in different spatial wavelength, and we'll be identifying those spectral response curve of each and every soil. Then we'll be identifying the soil texture, the soil type, the soil minerals, the rock types. So you can see on the right hand side there are various kinds of rock types like granite, rhyolite, cyanite. So each and every rock type behave differently in different spectral map, and we'll be recording those spectral signatures to identify those rock types, and finally we'll be going into the field and we'll be verifying the data sets. These are some of the energy, how the backscattered microwave data is being recorded for rice, water, urban, and other crops, and how those field data are being sensed and has to be gone into the field. You will be seeing the pre-transplantation, then when you are transplanting it, then when you are tilling, when you are vegetating it, when you are peak vegetation, when you are heading, and finally maturity. So these are the various stages through which any vegetation has to go through in his life. And you can see that how different earth objects that like rice, like water, urban area, and other crops behave differently in different spectral channels, and we'll be identifying all those spectral channels of each and every land use land cover feature for identification, for mapping, for monitoring, for performing the multi-temporal analysis. So we have already stated and studied that we have got three types of platforms. One is spaceborne, other one is airborne, and the third one is groundborne. So groundborne generally we are restricted to local study for a particular plot or particular agricultural area. We'll be using a spectroradiometer or image snapshot, and we'll be verifying the spectral response curve generated from the satellite image, and then we'll be mapping the same earth object in through a spectroradiometer, and we'll be seeing the accuracy of the data, what is the accuracy and which data is more accurate. So such kind of studies can be done using ground-based instrument. For airborne. Now each and everyone is very familiar with the term UAVs, unmanned air vehicle, and drones that are using for crop acreage, crop yield, and for regional studies. And finally, you'll be using the space-borne satellite images, where we'll be using the various satellite data from Landsat, IRS, Siri, RESAT, INSAT, MOD, CRS-1, RadarSat for different type of crop acreage estimation, crop patch, change pattern delineation, yield modeling, crop damage, crop disease. So whatever things that comes to your mind, each and every question, each and every problem will be solved using remote sensing and GIS technique. So you can see that how different earth objects are viewed and The satellite images capture the entire images of the entire world, how this is located in different rows and columns, and how they are being sensed. So you see that as the height of the satellite images increases, the amount of area coverage increases, and with the area coverage increase, the amount of information of the object that is being sensed by the satellite also increases, and that is known as synoptic coverage. That is also indicative of spatial resolution. Then you have got a revisit time of each and every satellite that has got a swath area. The total amount of coverage that is covered in a single seat is known as swath area. So for each and every satellite, you have got a different swath resolution as well as different orbits and sensing of the area. So the commonly used data sets that we are using is passive remote sensing data, where we are using electromagnetic data set, in which we'll be using the optical data set. That is, when we say optical, we are talking about blue band, green band, near infrared band, red band, then thermal band. When we are talking about near infrared band, middle band, thermal bands, and microwave data. They are the longest bands for which are generating their own source of energy, and the back scattered energy is being recorded by the sensor. So it is a capacity of being handled in all weather conditions. So that is also known as active remote sensing, in which we are using lidars, radars for sensing the object, and we are also using polar satellite images, geostationary satellite images, where we are concentrating and we are mapping any earth object on the basis of its spectral resolution, temporal resolution, spectral and radiometric resolution that we have already stated, already discussed. Like a spatial resolution denotes about the size of a pixel or the ability of an sensor to differentiate between two different objects. Temporal resolution is denoted to the revisit time of the satellite. Spectral bands denotes to the different kinds of bands that are available in the satellites, and will be using those bands for identification of various Earth objects. And finally, the emissivity of the data, the form in bytes, how many bits data set is, and that depends on your radiometric resolution. Finally, you have got different kinds of data sets and products, and finally we'll be calibrating it and we'll be validating the data sets to take out our area of interest. Some of the example is how these satellites are being sensed. So you can see that how they are seen, the in the picture, how they are seen, their manufacturing, and how they record the object. And these are some of the pictures of those sensors. So we'll start off with the application, how this remote sensing data are commonly used for delineation of various Earth objects. Like in the first image, you will see advanced wide field sensor AVIX with a spatial resolution of 56 meter, and that has got a revisit time of 5 days. Thereafter, the spatial resolution increases. Then we have got linear imaging self scanner with a spatial resolution of 24 meter, and the revisit times is 24 days. And then you have got lease 4 with a spatial resolution of 5.8 meters. So you can see that as the spatial resolution is increasing, the amount of information is increasing. And finally, we'll be using the Cartosat dataset, which is of very high resolution, but they are panchromatic images for mapping and monitoring of various natural resource uh, systems. So you will be seeing that different, each and every satellite has a different channel. So we'll be using the coastal channels of 8 kilometer radiometric for Kalpana, and the different bands are optical bands, thermal bands, shortwave infrared bands, middle infrared bands. Then you've got a multispectral inside 3A showing the vegetation and snow. So using this satellite data sets are used for various kinds of weather forecasting, weather preparedness. So such data are being used for that. Apart from that, we are using the various geophysical and biophysical projects like NDVI, rainfall, land surface temperature, insulation using the MOSTEC data sets from Kalpana, INSAT, 3A, 3D, 3DR, and we are generating at India level the various kinds of vegetation indices, rainfall pattern, daily solar radiation, land surface temperature. So anybody by seeing the map can understand ki what is the rainfall, what is the pattern, whether the rainfall is static or changing, whether what was in 1920, what is in 1960, what is in 2000, what is in 2020, and it can be applied. The same principle can applied for vegetation, can applied for solar radiation, can applied for land surface temperature, and we can see that how the natural system ecosystem has changed over the decades, or whether what damage do we the human being are doing to the environment. So such kind of studies with a precise location understanding can be provided using remote sensing and GIS data sets. So you can see that if the same thing was provided in the form of tables or graph or any data sets, that was very tough to identify and visualize. But the biggest advantage is when you are using the remote sensing data, that helps you to visualize the data in more effective way, and you can sense it at a larger level. So you can see that nowadays ISRO, Government of India, are using the INSAT data for mapping the solar energy hotspot using INSAT. So you can see that which are the area which are hot more than 2500, then 2000 to 2500, then 1500 to 2000, then 1000 to 150, then less than 150. So all such kinds of annual estimation of solar energy monitoring can be done using remote sensing data. So you can see that anybody can easily visualize the data set and can understand the kind of solar illumination that we are sensing, and that is of great use for nowadays when you're talking about an alternative source of energy. And the alternative source of energy, what we are talking about solar energy, we are talking about wind energy. And for that estimation of solar energy, what are the energy, which are the suitable sites, what is the total amount of energy or solar illumination, insulation, what any area is receiving. So such kind of analysis, if you are not using satellite images, it's very tough to identify what is the current scenario and what is the future scenario. So using the remote sensing and satellite images, we can see past, we can map present, and we can model for future. So you can see that how the agricultural pattern is changing in the entire India. You can see that how this pattern are changing over the decades. What was the situation in 1st August? What was in 2nd August? What was in different years? And we can classify those pattern of rice, wheat, and cotton cultivation, which area are having the excellent production, which are at a very good, which are good, which are moderate, which are low, and their spectral profile can easily be delineated. So we can have a real-time understanding of the entire rice condition, wheat condition, or various kinds of agriculture, the practices we are doing, whether the practices what we are doing is sufficient enough to sustain the population. So such kind of studies can be easily done, where we'll be using the satellite images for forecasting the agricultural outputs, and that will be based on agrometeorological and land observation based satellites, where we'll be identifying the various types of vegetation like rice, that is multi-seasonal, that is Kharif and Rabi season. Then you've got jute, wheat, mustard, winter potato, cotton, sugarcane, pulses, groundnuts, maize, pulse, millet. So we can see that how the satellite images will be used for identification of various agricultural practice, whether the production is static, whether it's increasing, decreasing, what is the area, what is the expected uh, production, what is the moisture contained in that area, and what is the amount of information that has to be shared to the farmer. So each and every information can be shared, can be seen visually using remote sensing and GIS data sets. Not only that, we are also using for identification of different horticultural aspect management using geoinformatics. That yesterday class I've already discussed how we'll be using this remote sensing and data for different kinds of horticulture plantation like fruits like banana, mango, citrus, vegetables, potato, onion, tomato species. And finally, we'll be providing a decision support system which will be showing the different kinds of sites suitably post harvest infrastructure, crop intensification, GS database creation, outcut review, rejuvenation, aqua horti definition, and you can see the entire statistics at a area level, block level, what is the cultivation, and we can identify the different kinds of vegetation pattern, crop damage, crop disease delineation, identification of sort. We can even identify the each and every species. We can count the number of trees which are outside the notified forest using various kinds of study, and you can see that how the different kinds of plantation will be seen in the satellite images, and what is the reflectance of that object in the ground, and that has to be geotagged so that whatever understanding and result you are stating will be monitored, will be analyzed by various scientists. So you can see that we are going to identify the various kinds of crop estimation, what is the production in that area, and we have also discussed and we have seen that how the satellite images are used for Himalayan glaciers, mountain, because whenever you are talking about glaciers or forests, they are inaccessible terrains. There is no connectivity that is of international and national significance. So remote sensing help you to identify the different kinds of glaciering, what are the changes that are happening in the glacier, whether the snout, what are the ablation zones, what are the lateral moraines. So each and every accumulation zones, ablation zones, not each and every features can be easily identified using the satellite remote sensing, and we can see the amount of area that is changing over the decades. If we are talking about glove, you can see that what is the area of glove in 1998 and what is in 2016. So we can identify the areas which are at a high risk, and we can have management and planning so that in the low lying areas there is no flood like situation. So such kind of studies can easily be done using satellite remote sensing, where we'll be classifying the entire snow or glacier into various categories, and we'll be using the various indices to identify the various kinds of moraines, various kinds of debris covered under dry slope, and we are using the microwave data sets to identify the real-time avalanche study, and such informations are relayed to the different government agency, and that is also used for military purposes. Apart from that, not only we are using for the snow and glacier mapping, but we are also using for various kinds of development plan and regional plan that the urban and department is making. So using the satellite images, you can see that we can map the various kinds of village development program, on the basis of which we can show the various kinds of socio-economic condition of that area, whether that is related to population density, whether that is related to sex ratio, literacy, percent of total literate, marginal workforce, percentage of cultivators, percentage of STSC population, what are the various kinds of facilities, whether that is related to education, medical facilities, communication, irrigation. So each and every feature can be easily delineated using satellite images, and the secondary data can be joined with the primary data so as to have a basic understanding of the area, and finally we'll be using such kind of information for the land and water resource development action plan. Will be mapping the land use, land cover of the area, the groundwater trend analysis will be performed, will be mapping the various kinds of soil in that area, and the slope, topography, geomorphology, geology, And finally we'll be making a land use land cover map of that area where we'll be going up to level. We'll start from level 1 to level 5 classification, and we'll be intensifying the number of classes, and finally we'll be providing the land suitability index. What are the areas, what are the different kinds of land use, what are the different kinds of groundwater condition in that area, what are the existing roads, what are the new roads that can come up, so that the agricultural productivity to the market or to the cold storage can be easily sent. What are the railway station do those railway stations or railway uh, are sufficient in nature? What are the values of land and slope, then soil depth, soil texture, soil erosion, water body, catchment analysis? All such studies can be easily mapped, can be easily viewed. So you can see that all such study and maps were prepared using the satellite images, and anybody who is not having a basic understanding of GIS, but after seeing the map, after seeing the legend, after seeing the scaling, it can very well connect itself to the map, and he can understand whatever understanding or whatever information that the decision makers or the planners want to convey to the local authority or the villagers or the block development or authorities can be easily circulated using those maps. So not only that, we are also using the satellite images for various kinds of coastal studies, whether it's related to various kinds of mapping of geomorphological terrain in the coastal areas, or whether you want to see the habitat mapping of the fisheries in any area. So all such studies can be easily done. You can see in the multi-temporal data sets what are the catch probability, whether which zone they are having a high catch probability, which zone is having the low catch probability, what is the amount of chlorophyll contained in that area. So such kind of studies can be easily mapped, and finally we can have a simulation or optimization. We can see about the futures. Not only we are using the satellite images for the various natural resource management, but we are greatly uh, mapping the entire area in terms of disaster vulnerability, because you can see that if you see the entire terrain and you classify the terrain according to the various kinds of hazards, you'll be seeing that in the Himalayan front we are facing the severe problem of earthquake and landslides are there, and in the low lying as well in the Himalayan northeastern, northwestern parts, northeastern parts, there are recurrent problem of flooding not only in the Himalayan but in the Indo-Gangetic Plain, Odisha, West Bengal, Chhattisgarh. We are always facing such kinds of problem that is related to floods. On the other hand, if you go to the northwestern parts, the area is very prone to drought, earthquakes, tsunamis, cyclone. They are very common in the shoreline areas, whether you talk about Odisha, Western Bengal, Karnataka, Kerala. They are prone to various kinds of disasters. So you can see that each and every terrain, whether you talk of Andaman, Nicobar, each and every terrain is vulnerable to various kinds of disasters. So until unless you are not mapping it, if you are not monitoring it, and you don't have a early warning system that can create a havoc in that area. And the remote sensing and GIS provide the decision support system to the decision maker, that we can plan accordingly. We can create the various kinds of donations, and using those donation, anybody can understand whether he is situated in a high zone or a low zone area. And you can see that hydrometeorologically 20% of the land is flood prone, 8% of the land area along the coastal areas is cyclone prone, over 65% of the land under cultivation is drought prone. So you can see that a large portion of the land are susceptible to various kinds of disaster. Not only hydrometeorical disaster, but you have got geological disasters, like around 25% of the land area is earthquake prone. Himalayan and Western Ghats are landslides prone. Andaman and Nicobar, parts of East Coast and Gujarat are tsunami prone. So when you're seeing that the entire area is one or the other way is at a very high risk, so you need a decision support system or a computerized system where you can forecast, you can see, you can predict about the future. So you can see that the Space Application Center, ISRO, and the various government organization has developed various forecasting models, algorithms on the basis of which the areas which are expected to receive a high rainfall region, what is the wind condition in every area, what are the relative humidity, what is the monsoon prediction, what will be the status, how the monsoon pattern will change over the decades, whether we are going to have a normal period or a drought period or a high amount of rainfall is predicted in any area. So such kinds of information nowadays are being generated using the satellite based data sets where we predict the various amounts of disaster that can happen in that area, and those information are sent to NDRF and NDMA team and with the different government and the state department. So you will see that nowadays the amount of efficiency, the solution, the kind of preparedness that the government of India is more prepared, whether it in terms of State Department or whether you talk about the central department, all are managing well, and that is all because of the prediction models that the satellite images provides, whether that is related to cold heat wave or hot heat wave, or you are predicting various types of satellites with the what is the seasonal variation, what are the kind of monsoon water that is we are expecting to receive in the month of July, June, August, September, and finally we'll be advising the agriculture ki what are the kind of practices, what are the kind of precautions that they have to do during or post monsoon. Then various kinds of satellite cyclone atlases are prepared, and finally we are also using for energy prediction, navigation, advisories, extreme weather alerts. So nowadays the satellite images provides you a ultimate solution to each and every problem. So recently there is a cyclone. Not only each and every year you are facing the cyclone. So ISRO satellite saves, you can see at least 10,000 lives in Tamil Nadu. So we should must thank to all the scientists, the scientific personnel, the government of India, the various scientists, the NDMA staff, the NDRF team members that are very actively acting, and they are preparing the latest accurate data sets related to various kinds of cyclones, and they are predicting about their intensity. They are going to track what is going to be the pattern, what will be the expected date, what will be the prediction date, at what time it will reach, what is the kind of formulation when the cyclone is going to have a landform, when the cyclone landform occurs, what is the amount of error at which location. So such kind of studies nowadays it's very you're familiar with. So I'll not taking much into the detail because in the televisions you're each and every news channels reporters are also nowadays very active in showing the various kinds of maps, statistics prepared by the space application center personnel, and we are very fortunate enough that our country has got a very strong space research organization, and the scientists are very qualified, they are very active, they are very good researchers, and the entire humanity is being benefited from their lectures, their trainings, their map generation, and for us, they are acting as a god. So you can see that what is the impact of filing over the year, whether there is a change in the land use land cover pattern, what was the pre-monsoon, what is the damage post-monsoon will be seeing. So you can see the using the microwave data set, we are going to map the flood affected area. So this is a flood affected area where the black color is represented by flood affected areas. So we'll be using the different indices and index to map the accurate flood affected area, and then it will be superimposed with the pre-flood condition to see the amount of damage that has gone in any area. So you can see that in 5th September 2013 there was no flood in any area, but in 25 October these black zones are representative of the flood affected zones. So the multi-temporal data sets are used to identify the exact amount of area that is submerged in water, as well as we'll be overlaying our agricultural boundary to those flood affected areas to see the amount of damage that has done to those crops, and finally they nowadays that are linked to crop insurance. So the entire crop insurance, the settlement to each and every portion, to each and every farmer, is being done using satellite remote sensing data sets where accurate measurement of the area is done using satellite remote sensing. So satellite-based monitoring is very important. You can see the cloud burst, Uttarakhand. There was a recent flood where India is recently affected by extreme precipitation events during monsoon season, and the frequency of these events is increasing. So timely amount of such events has a huge societal impact and that can save life. Presently in India, there are many regions that are devoid of any ground-based observations, and in such cases, satellite observations are the best alternative. Especially SAC ISRO Ahmedabad has generated various algorithms for showcasing the extreme rainfall events during satellites have been developed. So we are very fortunate, we are very thankful to the Space Application Center that they are providing the real-time information related to various disasters, and those maps are being used by the various agencies which provide the accurate area of the flood affected regions, and those maps are regularly updated so that we can have a proper rescue planning, the proper rehabilitation measures can be taken it. Not only that, satellite data are also used for river level and flood simulation modeling from satellites. So you can see that how the remote sensing satellites are being used to identify the flood water simulation is being performed over the various parts of the earth, and we can see what was the flood level over the different dates and what was the carrying capacity of the river and what we are going to expect. So whether the current situation we are prepared enough or not, we have to see. Apart from that, we are also going to monitor our coastal erosion. So you can see the various kinds of erosion that has happened over the years, whether that is a positive change or negative change, can be easily mapped and delineated using the satellite images. And you can see that polar studies are also doing where we are going for various kinds of glacier studies. We are using the various kinds of satellite images for identification and mapping of those satellite images. Then air quality monitoring. So you can see that due to transform the instant data are being used to see the various kinds of aerosols. So you'll be seeing that in winter season there are a lot of pollution being in the various parts of the country like Delhi, Haryana, Punjab. They are recurrent. So satellite data provides you the detailed understanding of the area, what is the area, which are the area which are going to be severely affected. So you can see that how such a difference in the feature can be easily delineated. Then we have already discussed how the various satellite images are used for various kinds of land degradation, water erosion features are being identified using the satellite images, and we'll be identifying the various kinds of land degradation categories, whether it's related to vegetation degradation, water erosion, wind erosion, salinity, water logging, mass wasting, frost having, frost scattering, man-made grasslands, land with scrub, barren, rocky area, dunes, anti-dunes, glaciers, periglaciers, other agriculture irrigated. So all such features are being identified, and various kinds of studies are being done by government of India. You can see that how the wind energy, how the solar energy, the heat waves, the ocean energy are properly sensed, and you can use this data sets are now being also used for generation of renewable energies. So you can see the biggest advantage is overlay analysis in GIS, where multi-thematic layouts are overlaid over each other to provide the exact amount of information, whether you want to go for mineral exploration or whether you want for any exploration mining. So you have got a various Mosaic is there where you will be using the data sets related to the weather forecasting, extreme rainfall, weather forecast, sea So all such data are available in Mozdoc. You can go and you can find that data set and you can download those data set according to your field of investigation, and you can use all these data sets for your research. As well as ISRO is providing the various trainings and data sets using Vedas platform, where you can download the various kinds of software generated by the scientists of India. Then there are various laboratories, tutorials, various trainings are provided to the students on various topics of image interpretation, use of remote sensing. Our students regularly do participate. Many of your seniors have been selected. They have gone into the ISRO and they had an interaction with the scientists, and they're very happy to see and get real-time insight from the topmost scientists of India, where they share their experience, where they share their data sets, where they share the amount of knowledge that they have, and these are the field photographs and some of the locations. So you can use these data sets for Cartoset data sets are there, research data sets are there, so you can download those data sets from the Bhuvan websites, and you can use those data sets for estimation of the agriculture biomass over any area, or improving the forest biomass, or monitoring the flood, oil, forest area, or groundwater monitoring, coastal zone studies, landslide, land subsidence, mangrove characterizations, monitoring the dynamics of ice shield, mountain glaciers. So various kinds of studies are being performed by various scientists. So you have to read for the papers that we have already shared with you, and you can search for a few of the papers that your department is also having good research team, and we are very fortunate enough that you have got very high profile faculty members who have got a very good citations, and you can read their papers also. Myself, I have got a good publication in the field of disasters, hydrology, urban planning, forest fire, donations, and various applications in various fields. So you can go through those papers also, and we'll have a more in-depth understanding, practically oriented exercises we'll be doing in our coming days in our laboratories, where you'll be using this satellite remote sensing data sets for mapping and monitoring of various earth resources. And I think that you must now frame your objective of your research, the topics that you are going to do in your dissertation, as now you have got a clear understanding of how the satellite data sets are applied in various disciplines, to according to your interest, according to your knowledge, according to your understanding. You can choose any of the topics of your research, and parallelly you can start reading good research paper published in good international peer-reviewed journals, and then you can frame your topic, your objectives, your study area, which study area you're interested in, whether you will be taking study India as a whole, or you will be taking some village block, or you're going for some watershed management activity or water conservation. All depends on your objective and the application that you're interested in, and depending on that, we'll have more meetings towards that, and finally we'll come to your conclusion. And with this, I'll be ending my today's lecture, and you are going to have 10 minutes of GD group discussion, what we have done today, the doubts, if you have got any. Thereafter, there will be a quiz in your LMS. And with this, I'll end my today's presentation. Good day. Bye bye.